Have you seen this before? That's M87, a galaxy containing one of the largest black holes known to mankind at its core. And that jet coming out? Yeah, it's coming from the black hole. And I'm going to tell you how. It's called the Blandford-Znajek process. And this is the hardest video I've ever made. So active black holes have accretion disks. These are those rings of glowing matter that surround black holes in all of the pictures. Basically, they're just orbiting matter that's moving so fast that the internal friction heats them to millions of degrees. At that point, it's not even a gas, it's completely ionized plasma composed of charged particles. And charged particles moving in a circle make a magnetic field. This is called the Dynamo Effect. In particular, the magnetic field runs through the center of the accretion disk, passing right through the black hole. At this point, we can forget about the accretion disk and just think about the magnetic field that it produces. Most black holes are rotating, and what that means is that they have a so-called ergosphere. I have a video linked in the description on this that goes in more detail, but to summarize, a rotating black hole drags space around it. The ergosphere is just the region where space is being dragged so quickly that it's impossible to not move in the same direction as the rotation of the black hole. And the magnetic field can't escape this fate either. What was once a magnetic field pointing up through the axis of rotation of the black hole now spirals upwards. But as a consequence of this upward spiraling behavior and Faraday's law, there necessarily must be an accompanying electric field, well, more precisely a displacement field, but don't worry about that. Importantly, this electric field points downwards in the region contained by the spiraling magnetic field until it reaches the event horizon, and then it flows along the event horizon, radiating outward in the equatorial plane. But charges like to flow along electric fields, and black holes are typically surrounded by low-density plasma. That plasma will typically consist of electrons and protons, but as the protons are much heavier than the electrons, they move significantly less, and hence the electrons carry the majority of the current. And so those electrons flow in the opposite direction of the electric field, in from the equatorial plane and then up and out through the region where the magnetic field lines are spiraling upward. And the result? A jet! Now the Blandford-Znajek process is not actually the only process that might contribute to jet formation around supermassive black holes. There's a similar process that occurs strictly in the accretion disk and doesn't require an ergosphere called the Blandford-Payne process. But that's a story for a different time.